Hello friends and my dear students, I welcome you all to my channel. This video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. In this video I am starting the next chapter, that is algebraic expressions. This is class number 1, and in this chapter I will start from the very basics of algebraic expressions, which you have already learned in your previous class, that is class 6. So we will again recall the concepts of constants, variables, literals, factors, terms, coefficients, like, unlike terms, constant terms, and finally the algebraic expressions, because these are very important fundamental concepts for understanding algebraic expressions. And then we will learn about the addition, subtraction, multiplication and division of algebraic expressions. So this video will be very basic, but it's very important to understand the very basics of the algebraic expressions. So I thought it is essential that I recall you the fundamental concepts. So let's get started. Okay, so I have what is this? Window projection. I have no idea what is this. Anyway, so this let's start. So you already know what algebraic expressions are, and you have done addition and subtraction of algebraic expressions in your previous class, that is class 6. But let me quickly recall what you have learned so far. This is the very fundamentals or basics of algebraic expressions. So we will discuss about constants, variables, the factors, terms, coefficients, algebraic expressions, like, unlike terms, constant term, coefficient of an algebraic expression, literals. So I will not explain these. I will not go into theoretical definitions of these terms, but let's try to understand these terms and concepts through an example. So you see, I have an algebraic expression which says 7x square minus 5xy plus z cube minus y square x minus z minus 6. So what are the terms? I hope you will all be able to say what are the terms. The terms over here are 7x square minus 5xy z cube minus y square x and minus 6. So you know that an algebraic expressions is fundamentally an expression that is a combination of some constants and variables combined together with the mathematical operators plus, minus, division and multiplication. Now in this expression you can clearly see there are addition and subtraction operations, but is there any multiplication and division operation? There is no division operation, but of course there is multiplication operation, because the terms 7x square is a product of 7 and 2x, so the multiplication is there. Now what is the term? What is the term in an algebraic expression? The terms, if you are given an expression, algebraic expression, the terms are the individual parts that are combined with the plus and minus operators. Now so I have written the terms as 7x square minus 5xy z cube, the minus y square x and minus 6. Now initially you might be wondering why not the terms are why minus 5xy is the term, why not it is 5xy, and why minus y square x, why not the term is y square x, and why minus 6 is the term, why not 6 is the term. Well, to be very honest, I do not have an answer for that. As per my understanding by reading the books, the definition of an algebraic expression says that An algebraic or terms says that the parts of an algebraic expressions which are combined, which are separated by plus and minus are the terms. So as per that definition, I also sometimes wonder that the terms should be 7x square, 5xy, z cube, y square x and 6. But the terms are said, the terms in the book says the terms are 7x square minus 5xy, not 5xy, minus 5xy, minus 5xy, z cube, minus y square x and minus 6. So I hope you got the you got the idea what terms are. Now remember that in a term there will be no multiplication or there will be no plus or minus operations. A term is consists of consists of multiplication or division of constants and variables. Okay, constants and variables. Now these are the, we see that these are the terms. Now let's try to understand how terms are made up of. What are the components of the terms? So let's say this one, 7x square. A term is a product of one or more constants or variables. Now what is a constant? A constant is, both constants and variables are known as literals. Now this term is nothing but 7 multiplied by x multiplied by x. So it will not be possible to explain all the terms. So I am considering one example, 7x square. So I am trying to explain what a term is. So this term 7x squared is nothing but the product of 7 and 2x. So we have a constant, 7 is a constant, and we have two literals. I mean the same literal, but it's appearing two times. X literals. X is a literal. Now variables. Now literals. X is a variable literal constant. X is a literal variable, whereas 7 is a literal constant. Now 7, this is a literal constant, or it's very casually said it's a constant, that is a number. What is a literal constant? A fixed number. Everything is a number. A constant is a number, a literal is a number, a variable is a number. Now a literal constant means its value will never change, so it's a fixed number. A literal constant. What is now what is I'm not sure how to explain. Okay, so what is x? This is a literal variable. This is a literal variable, meaning literal variable, there are various names given: literal variable, generalized variable. I mean a number, literal variable, fixed number, literal constant. Literal constant is a fixed number, that is a number whose value never changes. 7 remains 7, it will never change. Now x is a literal variable because its value, okay, it's a number whose value is not fixed, or rather it varies, is not fixed or varies. Now my pen is giving really lot of problem. Is fixed, is not fixed, or can vary. That is a literal variable. Both 7 and x are literals. Now, what exactly is a literal? A literal is a symbol. A literal is a symbol that represents a number. 7 is a symbol that represents a number. X is also a literal that eventually will represent some number, but that the value of the number will change. That is why it's a variable. So it's a literal variable. And 7 is since it's a constant and it's a symbol, it's a literal constant, and x is a literal variable. So both 7 and x are literal, but 7 is a literal constant, that is its value will never change, but x it's a literal variable because its value can vary. That is why it is said a variable. What is the meaning of the variable? Variable means something that can vary. Okay, so our terms you can see is 7 into x into x. The term is 7x square is nothing but 7 multiplied by x into multiplied by x, but we write it as 7x square. Now, what are the factors of 7x square? My pen is really giving problem. Let's try to understand the factors of x. Factors of x. Right. What are the factors of x? What is a factor? A factor is related to a term. A factor is associated with a term. When you ask a factor, you say that factor of this term. So a factor is a product of one or more variables or constants appearing in a term. A factor is a product of one or more constants or variables appearing in a term. So if I ask what are the factors of the term 7x square, the answer will be the factors will be 7, x and x square. 7 is a factor, and 7 is a factor, x is a factor, and also x square is a factor. But do not say that 7x square is a factor. No, 7x square is a term. 7x square is the term. So you see, in all the factors itself are product of one or more constants or variables. So these are the factors of the term 7x square. Now, okay. Now let's try to understand coefficient. What are coefficients? Coefficients are also associated with a term. When you say coefficient, you ask what is the coefficient of a factor in a term. Now I'm discussing coefficients. Okay, let's try to see if we can okay, for this term 7x square, coefficient of 7 equals coefficient of 7. Now I said that coefficient we talk about coefficient of a factor in a term. So we know that the term 7x square has the factors 7, x and x square. So we can ask what is the coefficient of 7 in the term 7x square, what is the coefficient of x in the term 7x square, or what is the coefficient of x square in the term 7x square. Now coefficient of 7 in the term 7x square will be everything, but you just leave the 7. Everything that is left in the term, you consider everything but not 7. So x square. If you leave the 7, then in the term what remains is x square. Similarly, coefficient of x is, I leave x, remember the term is 7x square. So if I leave x, what remains is 7x. So the coefficient of x in the term 7x square is 7x. Similarly, the coefficient of x square in the term 7x square is, you leave the 7x square and what remains is the coefficient, that is 7. Now, these are known as variable coefficient, because the coefficient has variables or literals whose value varies. So these are variable coefficient, whereas this one 7 is a numerical coefficient. Is a numerical coefficient. 7 is a numerical coefficient. Okay. Now, so we understood, we discussed about the coefficient of a factor in a term. Coefficient of a factor in a term. So, if you, just for your understanding, let me quickly explain what will be the coefficient, what are the possible coefficients. Okay, let's say let's take the term minus y square x. Factors. What are the factors of the term minus y square x? The factors are minus 1 x y y square x y what else? Now, actually it will be more. I can say should we consider minus x minus y and minus y square x? Factors, no, I think this is fine. The factors will be minus 1, that is the numerical part of the term. Minus means it's minus 1. Now this, what is this? This is nothing but minus 1 multiplied by y multiplied by y multiplied by x. Now the factors will be any combination of the constants and variables that you can think of from the term. So I can take minus 1, I can take y, 1y, I can take y square, I can take xy, I can take y square, I can take yeah, I think it should, the minus x will also be minus x minus y minus y square minus xy. Yeah, these are the factors. These are the factors. Now, let's try to understand some coefficients. Coefficient of, let's say, coefficient of y square. I am talking with respect to the term minus y square x. Coefficient of y square will be minus x. Coefficient of x will be, you just leave x and whatever remaining is the coefficient, minus y square. Coefficient of xy is minus y. Coefficient of uh, coefficient of what else, y square. Yes, coefficient of minus xy. If you consider coefficient of minus xy, it is y. Coefficient of minus y square, I hope you are getting the idea, is x. So like this. So these are what we mean by coefficient of a factor in a term. It is nothing but you whatever is remaining, if you discard the factor from the term, whatever is remaining, that is the coefficient of that factor in the term. Now, two things to keep in mind, that coefficients are of two types: a variable coefficients, meaning in the coefficient, if there is a variable or a literal variable like a variable literal or literal variable, which we denote it by small letters a, b, c, d, x, y, z, any coefficient which has some literal variable, so they are variable coefficient. And if in a coefficient, if there are no literal variables, it will be a numerical coefficient, that is, it has only some constant. So in the term minus y square x, the numerical coefficient is minus 1, and numerical coefficient is minus 1. So we can write coefficient of y square x equals minus 1. Now, what is coefficient of a term? So far we were discussing coefficient of a factor in a term. Now, what is coefficient of a term? Coefficient of a term is coefficient of a term is the numerical part of the term. So coefficient of, let's say I am discussing with examples only. Let's say the coefficient of x square, coefficient of term 7x square is, you consider only the numerical part, that is 7. Similarly, coefficient of term minus y square z is minus 1. Only the numerical part, only the numerical factor of the term. So let's take some examples more. Minus 5xy minus term coefficient of term minus 5xy is minus 5, and let's say coefficient of term minus 5 is obviously minus 5. So I hope the concept of a term, its factors, coefficient of a factor in a term, and the coefficient of a term is clear. So the z cube, it's the coefficient of the term z cube is 1 because the numerical part is 1. The coefficient of the term 7x square is 7 because the numerical part is 7. Now, okay. Now, what is a constant term? Constant term. Constant term is talked about for an algebraic expression. A term that has no literal factors is known as a constant term. So in this case, in this example, for this algebraic expression that we are discussing, the constant term for this the constant term is minus 6. This is the minus 6 is the constant term because it has no literal factors. There is no variables like x, y, z. It is purely a numerical. It has only a constant term. You can think constant term like this, a term which has only one factor, and that is a literal constant. Okay, so that is a constant term. Now let's try to understand what are like terms and unlike terms. Like terms and unlike terms. Now, two terms are said to be like if they have the same literal factors. If they have the same literal factors. Okay. Now let's take some concrete examples. Like unlike terms. So 5x and let's say minus 3 by 2 x are like terms because the literal factors of 5x is x, and the literal factors of 3 by 2 is also x. So the definition of two terms to be like are said to be like terms if they have the same literal factors. Now 5x, the literal factors of 5x is x, and also the literal factors of minus 3 by 2 is minus 3 by 2x is also x. Similarly, minus 2 x square y and y x square are like terms because minus 2 x square y, its literal factors are x square and y, and the second term y x square, its literal factors are also y and x square. Okay, I hope you got the idea, but minus 2x and minus 2x square are not like terms because the first term minus 2x, its literal factors is x, whereas the literal factors of minus 2x square is x square. Now you might be wondering that now when I say that two terms are said to be like when they have the same literal factors. They have the same literal factors. That actually means, now you might think, based on that definition, you might think that the minus 2x square, its literal factors are minus 2x the literal factors, the best way to understand the concept of two terms being like is that you first list down all the literal factors. Now, along with if there are multiple same literal factors, then you combine that same literal factors into powers. Like for this one I said, as per the definition of factors, if you see 7x square, I said the factors are 7x and x square. Now that is true, but when you try to understand when two terms are like, you have to consider the literal variables, the literal factors. Now in this case, minus 2x square, we are only considering the literal factors, so this will be the only x square. Now what does the definition say? That two terms are said to be like if they have the same literal factors. Now it is very confusing the languages given in the book, but the fundamental concept is that you consider all the different literal factors, and if there are multiple, if there are powers of any literal factor in the term, then you consider that power as a single literal term, that power of the literal factor as a single literal factor. So in the term minus 2x square, the literal factor is 2x, the literal factor is x square, and for this term minus 2x, the literal factor is x. Now, so x square is definitely not same as x, so they are not like terms. Let's take some few more examples. Let's say minus x y square z and y square x z are like terms. Why? Because the literal factors for this, the literal factors are y square, x, z. For this, the literal factors are x, y square and z, and you see both the literal factors are same, both the terms have the same literal factors. So in this way you have to understand whether two terms are like or not. Now let's say another example. Let's say y by x and yx are not like terms, Over here, for this term, the literal factors are x and y. For this one, the literal factors are y and 1 by x. So there is a common literal factor y, but the second term has x as a literal factor, whereas the first term has 1 by x as a literal factor. Definitely 1 by x and x are not the same. Let's take another example. Minus 2 x square y cube z square and minus 5 by 2 y cube x square z square are like terms. Because over here the literal factors are y cube x square z square. In this, the literal factors are x square y cube and z square, and you see both the terms have the same list of literal factors. So this is the concept we have. So this is the definition of two terms being like. A few more examples, because this is very important to understand. Minus 5 x y and minus 5 x y square are not, writing like terms, LT. Writing LT for like terms are not like terms, because over here for this the literal factors are x y square. For this one the literal factors are x and y. X is a common literal factor, but the first term has y as a literal factor, whereas the second term has y square as a literal factor. So they are not like terms. So I hope you got the idea of like and unlike terms. Constant terms where there are no literal factors. Like it's only a numerical part, it's a constant. They are known as constant term. What else? Coefficient of an algebraic expression. Now we have coefficient of an algebraic expression. This is wrong. This is wrong. Not coefficient of an algebraic expression, but coefficient of a term. It should be term. So I think I have covered all the terms that I wanted to explain. So the main thing is that for a given algebraic expression, you have to understand what are the terms. What are the terms? Now, what are the terms, and what are the factors of a terms? What are the factors of a terms, and what are like and unlike terms? What is a constant term, and what is the coefficient of a term? Coefficient of a term means only the numerical part of the term. So the numerical coefficient of a term is also known as the coefficient of a term, and the coefficient of a factor in a term. These are all the main concepts, like and unlike terms. So let's say if we are given an algebraic expression x minus y plus z divided by 2. This is an algebraic expression. Let's say I'm in short writing AE. Let's say this is an algebraic expression. Now, how many terms are there? How many terms are there? If you say 1, it will be wrong. So remember that the terms of an algebraic expressions are separated by plus and minus. So this is nothing but x by 2 minus y by 2 plus z by 2. So terms are x by 2 minus y by 2 z by 2 are the terms. Okay. Let's say another algebraic expression. Minus 5 x to the power 4 plus x y z minus 4 x y z plus y square x minus 3 minus y cube by 5 plus, let's say, 7. This is an algebraic expressions given. Now, what are the terms? If you are asked what are the terms, the terms will be minus 5 x to the power 4 x y z minus 4 x y z y square x. Now 3 minus y cube by 5, that is not a term. The term actually will be after y square x, another term will be 3 by 5 minus 3 by 5 minus 3 by 5, then 3 minus y cube by 5, you have to expand it, split it as 3 by 5 minus y cube by 5. So this, and we will have y cube by 5, and we will have 7. But this is also incorrect, because minus 3 by 5 plus 7 will need to be merged, and whatever that value is, minus 3 by 5 plus 7, that will be the term, and that is the constant term. Now, so terms will actually be, these two will get merged. 7 minus 3 by 5, how much is 7 minus 3 by 5? This is 35, so 32 by 5. So actually the terms will be, this will not be there, this will not be there, we will have 32 by 5. 32 by 5. Now, in these algebraic expressions, we have these terms. Now, the like terms are, these two are like terms. These two are like terms. These two are like terms. Similarly, what else? No, there are no other like terms. Now, constant term was actually minus 3 by 5 plus 7, which is 32 by 5. This is the constant term. And yes, what else? This is the constant term, this is the constant term. Like terms are x, y, z and minus 4 x, y, z. And if you consider, okay, let's quickly write the coefficient of all the terms. The coefficient of all the term, let's say, and this one is here the coefficient. So term for minus 5x to the power 4, the coefficient is minus 5, because what is coefficient of a term? Only the numerical part of a term. So xyz is 1, minus 4xyz is minus 4, y square x is 1, y cube by 5 is 1 by 5. Yeah, that's it. So I hope this video will be beneficial to you for understanding. These are the very basics of an algebraic expressions, like what is an algebraic expression, what are terms, what are factors, what are constant terms, what is a constant term in an algebraic expression, what are like and unlike terms, what is the coefficient of a term, and what is the coefficient of a factor in a term, literals, variables, constants. I hope you got a pretty good concept about these fundamental things of the algebraic expressions. These you have already learned in your previous classes, but I thought that it should be very clear for understanding algebraic expressions and moving on further, like addition and subtraction of algebraic expressions, and then multiplication and division of algebraic expressions. So I hope this video was beneficial, and let me know, give me your feedback how this video was. If this video was beneficial, then consider liking it, sharing it with your friends, and in the next video I will discuss about addition and subtraction of algebraic expressions, which you have also studied in your previous class, but just to recall, I will make a video on that, and then we will move on to multiplication and division of algebraic expressions. So once again, thanks for watching, and until the next video, take care and bye.